So for this example, we want to graph f of theta equals -3 cosine of 2 pi theta plus 2 over 1 period. We're going to be graphing using the transformation method again, so please remember to look at that video that fully explains this process, but it's worth pausing the video now to look through this process one more time so you're comfortable with everything we say as we go through this video. So remember, the first thing we want to do is to graph or make the inequality, make the inequality first and solve it. So we have 2 pi theta is greater than or equal to 0 and less than or equal to 2 pi. To solve for theta, we're going to divide all parts of the inequality by this 2 pi to get our theta alone, which gives us theta is greater than or equal to 0 divided by 2 pi is just 0, and less than or equal to 2 pi divided by 2 pi, which is 1. So between 0 and 1, this will give us the graph of 1 period as we know it of cosine, just as we would have before from 0 to 2 pi. There's just going to be some horizontal transformations applied to it already, which saves us the need to write down all the horizontal transformations later. Now that we have this, we now find p equals 2 pi over b. So p equals 2 pi over b, in this case, is the number multiplied to theta. Well, the number multiplied to theta is 2 pi. So we get p equals 2 pi over 2 pi, which is 1. And again, that can be found by taking the right side of your inequality and subtracting the left side from it. But it's a better habit to use this formula, as it'll be more useful as you go through trigonometry. So we find the period is a distance of 1. Now we want to take that period and divide it by 4, which gives us p over 4 is 1 over 4. And that's our number that we're going to add 4 times to the initial part of our inequality, which will give us our new 5 quadrantal angles, so to speak, our easy values that we already have pre-recorded y values for. So we start with our table for theta, and we're going to start with the first part of our inequality, which is 0. That's the -c over b. That's just the left hand of your inequality. And now we add 1/4 to it 4 times. 0 plus 1/4 is 1/4. Plus 1/4 again is 2/4. That's 1/2. Plus 1/4 again is 3/4. And plus 1/4 one more time will get us 4/4, which is 1. And it's a good idea to check that the first and last values of your table match up with the inequality so that you know you're on the right process here. Remember, these values on the y part of our table represent this, cosine of 2 pi theta. And they will always be the values in that table. That's the nice thing about this method. It's always going to be 1, 0, -1, 0, 1. So if you just memorize those tables, you can just plug them in once you've solved your inequality and gotten to this step. Now that we have this, we can now list our transformations. And remember, we only need to list the vertical transformations because the horizontal transformations were taken care of with this inequality process. So the first vertical transformation we have is this negative. We're multiplying by a -3 to the outside of cosine. Because it's on the outside, it's a vertical transformation. Because it's a negative being multiplied, it is a vertical reflection. From there, we're multiplying by a factor of 3. Because you're multiplying by 3, that is a vertical stretch. Remember, if it's between 0 and 1, it'd be a vertical shrink or compression. So by a factor of 3 tells us we have a vertical stretch. And you can put by 3, but there's no need to do that. It's more for your notes. And finally, we have this plus 2. That means that the entire graph is shifting up 2. That is our last vertical transformation that we need to make note of. So if we graph this table, and then we apply a vertical reflection, vertical stretch, and a shift up 2, we will get the graph of f of theta over 1 period. So let's go through that. We're going to start by graphing these points. We need x values between 0 and 1. So we'll put x equals 1 here. Halfway between 0 and 1, we'll have 1/2. Halfway between 1/2 and 0, we'll have 1/4. And halfway between 1/2 and 1, we'll have 3/4. We'll have our y values going from 5 to -5. If we need to add more, we can add them as we go. These are pretty large vertical transformations, so that may be the case. But as we fill these in, we have the point 0, 1. Then we have the point 1/4, 0. -1 for the y value when we have x equals 1/2. Then 3/4, 0. And then 1, 1. When we connect these dots, remember we have that curved shape that we follow. And we end up getting the graph of 1 period of cosine with our horizontal transformations applied. Now we need to apply our vertical transformations. We're going to go ahead and do the vertical reflection in green. So remember, a vertical reflection means you multiply every y value by a -1, or you can refer to it as taking everything above the x-axis and flipping it down, everything below the x-axis, flipping it up. So I just like to take these 5 points that we have and multiply them by a -1. We have 1 here, it's going to become -1. 0 will stay 0. -1 is going to become +1. 0 will stay 0 again. And +1 is going to become -1. Connecting these dots, we get the following graph. Now, we're going to go ahead and do the next one in yellow. We have a vertical stretch by a factor of 3. That means every y value will be multiplied by 3. It's going to stretch away from the x-axis. So this -1 is going to become -3. We're multiplying it by 3. The 0 is going to stay 0. This +1 is going to become +3. 0 will stay 0. And -1 will become -3 again, roughly here, which when we connect these dots will give us the following shape. And for the last vertical transformation, I'm going to do it in red. We're going to shift the entire graph up 2. So at -3, we're going to shift up to -1. 0 is going to go up to +2. +3 will go up to 5. Luckily, it fit with our y values we had pre-plotted. 0 will also go up to +2. And -3 will go up to -1. Connecting these dots, we get the following graph. This is the graph of f of theta over 1 period. And remember, it's a good idea to list your function name on your final graph. This is equivalent to circling your final answer, as you obviously don't want to circle the graph. It's going to look like it's part of your answer. But what you see here is the graph of one period. If we wanted to, we could travel a distance of 1 to the left or right, since that is our period, and redraw this exact same graph to get another period for f of theta.